Environmental engineering is the integration of science and engineering principles to improve the natural environment, to provide healthy water, air, and land for human habitation and for other organisms, and to clean up pollution sites. Environmental engineering can also be described as a branch of applied science and technology that address the issue of energy preservation, production asset and control of waste from human and animal activities. Furthermore, it is concerned with finding plausible solutions in the field of public health, such as arthropod-borne diseases, implementing law which promote adequate sanitation in urban, rural and recreational areas. It involves wastewater management and air pollution control, recycling, waste disposal, radiation protection, industrial hygiene, environmental sustainability, and public health issues as well as a knowledge of environmental engineering law. It also includes studies on the environmental impact of proposed construction projects. Environmental engineers study the effect of technological advances on the environment. To do so, they conduct hazardous waste management studies to evaluate the significance of such hazards, advise on treatment and containment, and develop regulations to prevent mishaps. Environmental engineers also design municipal water supply and industrial wastewater treatment systems as well as address local and worldwide environmental issues such as the effects of acid rain, global warming, ozone depletion, water pollution and air pollution from automobile exhausts and industrial sources. At many universities, environmental engineering programs follow either the Department of Civil Engineering or the Department of Chemical Engineering at engineering faculties. Environmental civil engineers focus on hydrology, water resources management, remediation, and water treatment plant design. Environmental chemical engineers, on the other hand, focus on environmental chemistry, advanced air and water treatment technologies and separation processes. Additionally, engineers are more frequently obtaining specialized training in law and are utilizing their technical expertise in the practices of environmental engineering law. Most jurisdictions also impose licensing and registration requirements. Development. Ever since people first recognized that their health and well-being were related to the quality of their environment, they have applied thoughtful principles to attempt to improve the quality of their environment. The ancient Harappan civilization utilized early sewers in some cities. The Romans constructed aqueducts to prevent drought and to create a clean, healthful water supply for the metropolis of Rome. In the 15th century, Bavaria created laws restricting the development and degradation of alpine country that constituted the region's water supply. The field emerged as a separate environmental discipline during the middle third of the 20th century in response to widespread public concern about water and pollution and increasingly extensive environmental quality degradation. However, its roots extend back to early efforts in public health engineering. Modern environmental engineering began in London in the mid-19th century when Joseph Bazalgette designed the first major sewerage system that reduced the incidence of waterborne diseases such as cholera. The introduction of drinking water treatment and sewage treatment in industrialized countries reduced waterborne diseases from leading causes of death to rarities. In many cases, as societies grew, actions that were intended to achieve benefits for those societies had longer-term impacts which reduced other environmental qualities. One example is the widespread application of the pesticide DDT to control agricultural pests in the years following World War II. While the agricultural benefits were outstanding and crop yields increased dramatically, thus reducing world hunger substantially, and malaria was controlled better than it ever had been, numerous species were brought to the verge of extinction due to the impact of the DDT on their reproductive cycles. The story of DDT as vividly told in Rachel Carson's Silent Spring is considered to be the birth of the modern environmental movement and the development of the modern field of environmental engineering. Conservation movements and laws restricting public actions that would harm the environment have been developed by various societies for millennia. Notable examples are the laws decreeing the construction of sewers in London and Paris in the 19th century and the creation of the U.S. National Park System in the early 20th century. Scope: solid waste management. Solid waste management is the collection, transport, processing or disposal, managing, and monitoring of solid waste materials. The term usually relates to materials produced by direct or indirect human activity, and the process is generally undertaken to reduce their effect on health, the environment, or aesthetics. Waste management is a distinct practice from resource recovery, which focuses on delaying the rate of consumption of natural resources. The management of waste treats all materials as a single class, whether solid, liquid, gaseous, or radioactive substances, and the objective is to reduce the harmful environmental impacts of each through different methods. Environmental impact assessment and mitigation. Scientists have air pollution dispersion models to evaluate the concentration of a pollutant at a receptor or the impact on overall air quality from vehicle exhausts and industrial flue gas stack emissions. To some extent, this field overlaps the desire to decrease carbon dioxide and other greenhouse gas emissions from combustion processes. They apply scientific and engineering principles to evaluate if there are likely to be any adverse impacts to water quality, air quality, habitat quality, flora and fauna, agricultural capacity, traffic impacts, social impacts, ecological impacts, noise impacts, visual impacts, etc. If impacts are expected, they then develop mitigation measures to limit or prevent such impacts. An example of a mitigation measure would be the creation of wetlands in a nearby location to mitigate the filling in of wetlands necessary for a road development if it is not possible to reroute the road. In the United States, the practice of environmental assessment was formally initiated on January 1, 1970, the effective date of the National Environmental Policy Act. Since that time, more than 100 developing and developed nations either have plan-specific analogous laws or have adopted procedure used elsewhere. NEPA is applicable to all federal agencies in the United States. Water supply and treatment. Engineers and scientists work to secure water supplies for potable and agricultural use. They evaluate the water balance within a watershed and determine the available water supply, the water needed for various needs in that watershed, the seasonal cycles of water movement through the watershed, and they develop systems to store, treat, and convey water for various uses. Water is treated to achieve water quality objectives for the end users. In the case of a potable water supply, water is treated to minimize the risk of infectious disease transmission, the risk of non-infectious illness, and to create a palatable water flavor. Water distribution systems are designed and built to provide adequate water pressure and flow rates to meet various end-user needs such as domestic use, fire suppression, and irrigation. Wastewater treatment. There are numerous wastewater treatment technologies. A wastewater treatment train can consist of a primary clarifier system to remove solid and floating materials, a secondary treatment system consisting of an aeration basin followed by flocculation and sedimentation or an activated sludge system, and a secondary clarifier, a tertiary biological nitrogen removal system, and a final disinfection process. The aeration basin activated sludge system removes organic material by growing bacteria. The secondary clarifier removes the activated sludge from the water. The tertiary system, although not always included due to costs, is becoming more prevalent to remove nitrogen and phosphorus and to disinfect the water before discharge to a surface water stream or ocean outfall. Air pollution management. Scientists have developed air pollution dispersion models to evaluate the concentration of a pollutant at a receptor or the impact on overall air quality from vehicle exhausts and industrial flue gas stack emissions. To some extent, this field overlaps the desire to decrease carbon dioxide and other greenhouse gas emissions from combustion processes. Environmental Protection Agency. The U.S. Environmental Protection Agency is one of the many agencies that work with environmental engineers to solve key issues. An important component of EPA Euro unregistered trademark's mission is to protect and improve air, water, and overall environmental quality in order to avoid or mitigate the consequences of harmful effects. Education. Courses aimed at developing graduates with specific skills in environmental systems or environmental technology are becoming more common and fall into broad classes: mechanical engineering courses oriented towards designing machines and mechanical systems for environmental use such as water treatment facilities, pumping stations, garbage segregation plants and other mechanical facilities. Environmental engineering or environmental systems courses oriented towards a civil engineering approach in which structures in the landscape are constructed to blend with or protect the environment. Environmental chemistry, sustainable chemistry or environmental chemical engineering courses oriented towards understanding the effects of chemicals in the environment. Focus on mining processes, pollutants and commonly also cover biochemical processes. Environmental technology courses oriented towards producing electronic or electrical graduates capable of developing devices and artifacts able to monitor, measure, model and control environmental impact, including monitoring and managing energy generation from renewable sources. Prominent environmental engineers, Robert A. Gearhart, Paul V. Roberts, Abel Wellman, see also, references. Davis, M. L. and D. A. Cornwell, Introduction to Environmental Engineering McGraw-Hill ISBN 978-0072424119, external links, American Academy of Environmental Engineers and Scientists, American Society of Agricultural and Biological Engineers, American Society of Professional Wetland Engineers, Association of Environmental Engineering and Science Professors, Confederation of European Environmental Engineering Societies, European Federation of Association of Environmental Professionals, Environmental Engineering Portal, Institute of Environmental Management and Assessment, Environmental Ethics, Wastewater Management and Air Pollution Control, Recycling, Waste Disposal, Radiation Protection, Industrial Hygiene, Environmental Sustainability, and Public Health issues as well as a knowledge of environmental engineering law. It also includes studies on the environmental impact of proposed construction projects, municipal water supply and industrial wastewater treatment systems as well as address local and worldwide environmental issues such as the effects of acid rain, global warming, ozone depletion, water pollution and air pollution from automobile exhausts and industrial sources. At many universities, environmental engineering programs. Environmental engineers study the effect of technological advances on the environment. To do so, they conduct hazardous waste management studies to evaluate the significance of such hazards, advise on treatment and containment, and develop regulations to prevent mishaps. Environmental engineers also design environmental engineering is the integration of science and engineering principles to improve the natural environment, to provide healthy water, air, and land for human habitation and for other organisms, and to clean up pollution sites. Environmental engineering can also be described as a branch of applied science and technology that address the issue of energy preservation, production asset and control of waste from human and animal activities. Furthermore, it is concerned with finding plausible solutions in the field of public health, such as arthropod-borne diseases, implementing law which promote adequate sanitation in urban, rural and recreational areas. It involves